Now we are going to start over here. The next topic, Bitset. It's very interesting topic. Bitset. We are following the same book and also some other resources. And Bitset here, not very bit means what? It's a 0, 1. By default, it is showing. If you are putting in a set, if you are putting in a open braces and close braces, if you set of that, you can mention as Bitset. Set means what? A flower brackets. In the flower brackets, we are going to be in a couple of flower brackets. If you are going to put it a pair of flower brackets, if you put it, then it is a bit set. Now, normally to represent any integer value, so for example, 2 can be represented as 0, 1. That is 1, 0. If for 3, it is represented as 1, 1. For 4, it is 1, 0, 0. For 5, 1, 0, 5. Like this, we can represent that values also in the form of this bits. Okay. Like we have in the operators, bitwise operators also be there. Like ampersand, logical, bitwise OR, it's a vertical bar, bitwise NOT. Like we have different operators were performing, like left shift, right shift. We are going to performing, right? So that also we can be performed in the help of Bitset class. So to customize, to flexible, to make very easy, this bit class has introduced in Java. Now coming to the definition of Bitset class, a Bitset class creates a special type of array. This set Bitset class creates a special type of array that will holds the values in the form of Boolean values. So already you are aware the Boolean values is nothing but 0 and 1, right? So Bitset class means that will create a special type of array. That array will be stores. Holds means what? Stores values in the form of Boolean values. Now this array can increase in size as needed. Whenever it is required, you can increase the size of this array. You can decrease it. So it based on the dynamical, you can also increase it. So this is a similar type of AND vector. So already in the max you have seen how AND vector will be. A vector can be represented in the form of the shape of the array type only, but it will be making use of the array and vector based on the context. In some context we are going to using array, in some context we are going to using vector. Like as I said you, for every class there will be a constructor. So to create the Bitset class constructors, we have two constructors. One is 0 parameter constructor, another is 1 parameter constructor. So by default, the first parameter, the first version creates a default object. The second constructor, what is the size n means? We are saying it is a create a special type of an array, right? What is the size of the array? If you want to mention manually, you can mention as this parameter as a this in the Bitset one. If you mention, say for example, it is a 10, the size is 10, it will create for 10 bits. It will holds this Bitset class constructor, it will holds 10 values. So the second version allows you to specify the initial size, that is the number of bits that can be hold. How many number of bits can be that can be hold, that can be shown over here. So initially, defaultly, it will be all the values, whatever it is going to be when it is creating a bit set by the Bitset constructor. Initially, all the values will be set to false. False means 0. Say for example, you created for 10 values, all the values initially is set to 0 only. Okay. Now, as a continuation, as I said, you for every class there will be constructors as well as they are may or may not be having some methods. So here we have more than 20 methods are available in Bitset. But for making use of very simple, we'll choose a few methods and we'll be execute some programs on that particular method. So whichever of the methods are comfortable, that you can please catch from this. So first method is like AND. What are the operators we can perform? Operations we can perform in the bitwise is bitwise OR, bitwise AND, bitwise XOR, bitwise left shift, bitwise right shift. Like this we are performing, right? So here there is a one is AND method. Next method, if you are comfortable, clear. Next method you are going to be making as equals. Next method we can get as get the value. Next method we can make as intersects. Next method is can calculate the length. And next method we can consider as OR. Next method we can perform like set. We can set the values of this one. Next method we can perform like say for example size. Next method we can perform XOR. So not only this, we have many more methods out there. For making of time being, in your examinations also, in your representing, please remember 5 to 6 methods over there. In this AND, there is a parameter is a bitset. The parameter we need to pass is bitset object itself, right? So we are passing bitset object here. Bitset class, it is an object. Is a how to create an object, class name followed by object name. So what will we do normally in bitwise AND? If both the bits are same, then it give the result as 1. If any one of the bit is different, then it gives us 0, right? Next, to clear all the bits, we can use the clear method here. And to compare the equals between two operators, we can use the equals method. If you want, the flip is there. Flipping, already know you're studying the DLD, digital logic design. You are going to studying over that. There you are having some inverters. There you're having some the performing OR operation, AND operations, left shift, right shift, two's complement, one's complement, like different things you are going to be doing in the DLD, right? The same will be make use of. With the help of that, you are going to mentioning with the help of this type of classes, this type of methods, you can implement such type of concepts over there. Like the flip, like we can have flip of the different parameters. Like also we can have the intersect. Intersect is nothing but what? It's like similar to the AND. If both are, if the two sets are there, set one, set two, both the common things which are in the both the sets, common elements which are there, that will be pick up for that, right? Like we can have the length, we can calculate, and we can also have the OR operations. OR operations nothing but what? Bitwise OR means if any one of the bit is 1, then the resultant is also 1, right? So we also have the set method. We can also have the size. We can also have the XOR. XOR, when we can say XOR, if the two sets, means two values of the bits are different, then the resultant is 1. Say 1 0, 1 is different, 0 is different. If both the bits are different, both the sets of bits are different, then it will give the 1 result. If both the bits are same, it will give 0 in XOR. So with the help of these constructors, with the help of this few methods, let me talk about a small demonstration on Bitset. Now, as you already aware, so this is available in the package called as java.util package. So java.util.bitset, I'm going to using importing this package. I'm creating a class called as bitset demo. I'm calling a method, main method here. Now I'm creating a 2 bitset objects, bits 1 and bits 2. What is the size of here? I'm using the second constructor. I'm using the bitset second constructor, it is a int size. What is the size I'm giving as? 16. For this also I'm giving as 16. Now I have creating, what is the 16 here? Nothing but, here 16 nothing but, it will start from 0 to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 0 to 15 means 16 bits are there. Now I'm going to be creating the 2 objects, bits 1 and also bits 2. 2 objects I'm going to create. Now what we are going to doing is we are going to be assigning some values for this one. We are need to initialize some values. So how to set that values is, here I am taking a for loop here for I equal to 0 to I less than 16, means for 15 times, 0 to 15, the loop will repeat. The element which is modulo with 2 and equal to 0, then I'm setting for bits 1. Bits 1 dot set. Already you know the method of set, right? Set of the particular value. Say for example, if you are taking the first value, I equal to 0, 0 modulo 2. What is the 0 modulo 2? It is a 0, 0 equal to 0. Condition is true. For modulo, what is the output? Remainder. So 0 modulo 2, when you are performing, the output is 0. 0 equal to 0. Condition is true. That 0 value is assigned to bitset 1. Next, 1 modulo 2 equal to 0. No. 2 modulo equal to 2. That is equal to 0. Yes, because whichever it is multiplied, that is divided by with 2, which gives the remainder 0. Like 0, 2, 4, 6, 8, 10, 12, 14. So these are all the elements which is going to be all the bits which is going to be assigning for bitset 1. Now I'm assigning some more bits for bitset 2. Another bits for bitset 2. How means? I'm just modulo with 5. If it is not equal to 0, such type of bits will be assigned to bitset 2. When you are performing with 5, which is modulo is not equal to 0, then that will be set that all the values are setting to bitset 2. So whichever the values between the 0 to 15, that is a bitset we have created, right? Because we have set here the 16, here also 16. So between 0 to 15, which are the values getting the 0? 5, if we modulo with 5, it will get 0. 10 modulo 5 will get 0. 15 modulo 5, it gets 0, the remainder. 0 not equal to 0, condition false. 10, that when you are performing with 5, condition false. 5, 10, 15. Except this 3, 10, 5, 10, 15. Except this 3, the rest of the bits you are going to be assigning for to whom? Except this 3 means including 0. 0 also not 0 modulo 5 is 0. 0 not equal to 0 means condition false, right? It will not be set. Except 0, 5, 10, 15, 4 values. The remaining 1, 2, 3, 4, 6 up to 9. Next from 11 to 14. All these values are going to be setting for bit set 2. Now, after executing these two statements, what are the values in bits 1? It's a 0, 2, 4, 6, 8, 10, 12, 14. Now, what are the values are available in this one? 1, 2, 3, 4, 6, 7, 8, 9, 11, 12, 13, 14. These are the values of bit set 2, except 0, 5, 10, 15 will assign to the bit set 2. And whichever the having even numbers, it will assign to bit set 1. Now, to display that one, what we are going to doing is, we are just displaying this values, initial pattern of bits 1. Initial pattern of bits 1 we are displaying here. This is the one output, right? Here, this is the output for bit set 1. Now, for this one, for bit set 2, initial pattern in bit set 2 is, this is bit set 2. Okay, so where it is here the bit set 2 pattern here. Okay, now this is just for, in this slide we are talking about, we are creating two bit sets, bit set 1, bits 1, bits 2 objects, and we are going to be assign some values in bit set 1 based on some condition. We are assign some values to bit set 2 based on some condition. We're just displaying. Now we have a methods, right? We are going to performing some operations here. Some operations we are going to be performing over here. Now, what are that operations? Let me see that operations here. We are performing AND here, AND, OR, and XOR. Now, how to call the AND method? We already know the syntax here in this one. We know how the syntax of AND of bit set of bit set. This is the object we need to pass. What is the parameter we need to pass to the AND method? The bits of the object we need to pass is bit set object. Now, how to call the bit set is bit set 2 dot AND of bit set 1. Now we are performing an AND operation between bits 2 and bits 1. Between these two bit sets, we are performing AND operation. Now, after performing AND operation, where is the resultant will goes? The resultant will goes in bit set 2. Okay, so that bit set 2 we are going to be display here. That's what, right? So when you are performing AND operation, bits 2 dot AND of bits 1 means the resultant of this 2 after performing AND operation goes to bits 2 only. Now coming to the example. Now here is the example, right? Now here is the values are there. Now this is bit set 1, this is bit set 2. Now when you are performing AND, AND operation here, AND operation, where is the values will goes? What are the values will comes here? AND means what? AND means both are intersection, means both the common values between this and this. What are the common values are available? That is 2, 4, 6, 8, 10 is not there, 12 and 14. So 2 is there in bit set 1, 2 is also there, 4 is there, 4 is there, 6 is there, 6 is there, 8 is there, 8 is there. Next 10 is not there, 12 is there, and 14 is there. So these are the values are available. Where it is stored, to whom I need to map? I'm mapping bits 2. Now currently in bits 2, what are the values? 2, 4, 6, 8, 12, 14. Now previously the bits 2 values are 1 to 14 except 0, 5, 10, 15. Okay. Now it is display the output as that. Now we are performing OR operation, OR bits. Now bits 2 dot OR of bits 1. Now we are performing bits 2 and bits 1 OR operation. Now where is the resultant of this OR operation? In again bits 2 only. Again the bits 2 only, it will be there. Now coming to the example. Now this is bits 2 now. It is not bits 2. This is not the bits 2. Now bits 1 after performing AND operation, the bits 2 array values are 2, 4, 6, 8, 12, 14. Now what are the bit 1 values? Bits 1 value, this one. So we need to perform OR operation between what? The OR operation between this and between this. This is bits 2. The OR operation between these two. Now between these two we are performing OR. Now what is OR actually? What is OR need to be done? The OR values are, what is the OR? the union. Union means whichever the elements are there in bits 1, whichever the elements are not there in bits 2, both will be combined together. So 0 is not there in bits 2, 2 is there, 4 is there, 6 is there, 8 is there, 10 is there, 12, 14. So except 0, 10, all the elements are there here. So it will be added, the total entire array between, we are merging bits 1 and bits 2. Now it is assigned again to whom? Bits 2. Now when you are performing OR operation, this is the output. Clear? Now it will display that output here. Now go for XOR operation. So bits 2 dot XOR of bits 1. We are performing bits 2 with bits 1 XOR operation. XOR purpose is what? XOR operation means when the two bits are different, then only the output is 1. If both the bits are same, it will be take as 0. Now we are performing XOR operation. Between whom we are performing XOR operation? Here is the XOR operation. Between whom we are performing? Between bits 2 and bits 1. Now what is the bits 2 value? This is the bits 2 value. Now what is the bits 1 value? Here it's the same. This is the bits 1 value. Now between these two we are performing XOR. Between these two we are performing XOR here. So when you are performing XOR here, now what will be there? If both the bits are same, it gives nothing. If both the bits are different, it gives 1. Means 0 here, here 0, 2 here, 2 here, 4 here, 4 here, 6 here, 6 here, 8 here, 8 here, 10 here, 10 here, 12, 12, 14, 14. Now what is the output of this one? It will give an empty. Empty because there is no, all the bits are common. In bits 1 and bits 2, all the bits are common. When both are same, it gives what? 0. 0 means empty array. Empty set it gives. If the bits are different, say for example, if I have here 5, now 0 to 4 is there, here 0 to 4 is there, nothing will be there. 6 is there, 6 is not there here. Now it is a 6 is different from this one, 6 will be there. Now 8, 10, 12, 14 is there, 8, 10, 12, 14 is there, and one more bit is there, 5. So 6 comma 5 are not there. 6 and 6 there is no matching here. 5 there is no matching. So what is when both the bits are different, that bits will be considered into this set. That is, it is going to performing in this set. Now this will be the resultant when you are performing, and is assigned to again bits 2 only. So when both the bits are same, that is 6, it gives only empty array, empty bit set. Okay, so we got this one. Let me run the program so that you can understand very clearly about this one. So here the program Bitset demo is already have taken this. Now this is the program. Now I'm importing the Bitset package, Bitset class, calling a main method, creating 2 Bitset objects of sizes 16, and I'm just assigning with the help of I modulo 2 for Bitset 1, I modulo 5 not equal to 0. That will be assigned the values to Bitset 2, and I'm just displaying Bitset 1 and Bitset 2, and now performing R and R XOR. This is AND operation. Up to here, this is OR operation, and this is XOR operation. Okay. Now let me run the program. So already we have opened the command prompt. So what is the name of the program? Is Java C space bitset demo.java. This is the program. If no errors, it will be run the program. Now run the program. Okay, I just Java. See the patterns for the Bitset one. What is the output? 0, 2, 4, 6 for this one. 0, 2, 4, 0, 2, 4, 6, 8, 10, 12 for this one, right? For this one, it is showing the output is like this. For this one, for this Bitset 2, the 1, 2, 3, 4, 5 is not there, 6, 7, 8, 9, 10 is not there, 11, 12, 13, 14, 15 is not there. When you are performing AND operation, what is the output? Actually, we have got it here in this demonstration. Here is the notepad. Here, the output of AND is 2, 4, 6, 8, 12, 14. Now here the output is 2, 4, 6, 8, 12, 14. When you are performing OR, the output is 0, 2, 4, 6, 8, 10, 12, 14. Now when you're performing here, the output of OR is 0, 2, 4, 6, 8, 10, 12, 14. When you're performing XOR here, both the bits, this bit set 2 and this is bit set 1. This is bit set 1. For this one, both are same element. So that's why it is giving empty set. So that's what we are getting here, empty set. Now, to understand very clearly about the XOR, what I'm doing here is, I'm just removing this R. So for example, for just removing this R operation, OR operation I'm removing here. This OR operation I'm clear. Now I'm just performing AND and OR, XOR. Okay, just save the program, compile it. To better understanding what actually the XOR, instead of getting 0 array, instead of getting the empty array, let me see the another array. Okay. Okay, fine. Here is the Java, right? Now see, this is bit set 1, this is bit set 2. It is common. When you are performing AND operation, same output 2, 4, 6, 8, 12. Now this is bit set 2, right? This is bit set 2. And when you are performing XOR, between this is bit set 2 and this is bit set 1. When you are performing XOR between these two, what will be there? 0 is there here? No. In this one, 0 is there? No. That's why it is added in XOR. 2 is there, 4 is there, 6 is there, 8 is there. 2, 4, 6, 8 is there. That's why it is not added. 10 is there here in this bit set 2? No. That's why it is added 10. 12, 14. 12, 14 is there. That's why it's not added. So when you are not having a different elements are there, then it will be added. When you have all the elements are same, it gives the empty array. Okay. So what we have done is we have just changes here. This is the change. And if you want, you can make the changes over there and also you can run the program so that you can understand very clearly about this one. So that's about the Bitset class. So what we have discussed in the Bitset classes, we have discussed about the constructor, followed by some methods and followed by some examples we have seen over there. So that's about the Bitset class in Java.